So now that we've looked at these concepts and ideas of finding the center of mass in moments, let's actually do an example of one. So we're going to find the center of mass for the triangular plate in the first quadrant bounded by the axes and the line x plus y equals 4 if delta is 1 plus x plus y, so that's our density function, in the units of grams per centimeter squared. Okay, so I graphed this in Maple just so we could kind of get a little look at it. Oops, sorry, I gotta scroll up. Right here. So I have my implicit plot. I was trying to get it to shade, but it doesn't shade as well as I would like. I know there's a way to do it, but I have to figure it out. I'm on kind of an older version of Maple here. So x plus y equals 4 as a line. It's the same thing as saying y equals 4 minus x, or let's see, x equals 4 minus y, either one. And then, of course, you're graphing from 0 to 4, 0 to 4. I'd put 0 to 5 in, but it doesn't make any difference. So you're looking at that region because it's bounded by the axes, so the x-axis, the y-axis, and that diagonal line. But it has a density function that's not uniform, so it's 1 plus x plus y. So I'm just going to graph that function right here, right? There's our diagram. And then that was shaded yellow. It doesn't look like it, but it was. So I'm going to make my y value go from 0 to the diagonal line. So I'm going to go from 0 to 4 minus x, right? Y equals 4 minus x. So I solved it for y in my head. And then I'm going to make x go from 0 to 4. Remember, you can't go 0 to 4, 0 to 4 because that would be a square, and this is not a square. So you have to have one of these have variables in it. And I just picked y, but you could have picked x just as easily. If you did x, it would be 0 to 4 minus y, and then y would go from 0 to 4. Okay, so I've got that. Now, to find the center of mass, remember that's this giant formula right here. So I'm going to need to find m, first of all, right? M is the mass function, which is the integral of the delta function, the density function. So that's my first mission. So I'm going to find my mass, m, which is that double integral of density over the area. Well, but I've got the area. It's this triangular region, so I'm going to type that in. So I'm going to go from 0 to 4 for my x, 0 to 4 minus x for my y, and there's my delta function. Okay, well, if we integrate this with respect to y, I'll get y plus xy plus 1/2 y squared. And then I'm going to take that from 0 to 4 minus x. So then I just want to stick the 4 minus x in there wherever there's a y. So that would give me 4 minus x plus x times 4 minus x plus 1/2 times 4 minus x squared, which I am not going to do that by hand. That is what Maple is for. And I will get it to tell me that the answer is 88 over 3. Just you wait. And there it is, right? So beautiful. There's the actual original integral I started with. And then if I'm forced to do some steps by hand by your evil instructor, then you can check yourself that it's the same right there. All right, so now that's just the first part of this. That's just m. But if I want to find the center of mass, I'm going to need my divided by m and mx divided by m. So I'm going to have to find mx and my. It doesn't really matter which one I start with. So I started with x bar, which is my over m. My is the distance from the y-axis, which we measure in x. So that's why that double integral is with x and then delta of xy dA. I believe that formula is right on your formula sheet, though. You don't have to memorize it or anything. So then I want to stick in my function, right? M we just discovered was 88 over 3. So it's 1 divided by 80 over 3 because I'm pulling that out because it's constant. So 1 over m. And then my limits of integration are the same as before. It's still the same triangular region. So it's still going from 0 to 4 minus x for y and 0 to 4 for x. But my function, instead of being the delta function, which was 1 plus x plus y, is now 1 plus x plus y times x. So that's x plus x squared plus xy. So then I just integrate this with respect to y. So, and also a reciprocal 1 over 88 over 3 would make it 3 over 88. So I just kind of reciprocate that fraction at the beginning, so 3 over 88. And then xy plus x squared y plus xy squared over 2. I'm integrating each of those three terms with respect to y. And then take them from 0 to 4 minus x. So I'm going to stick 4 minus x in there wherever there was a y. and that'll give me some, terrible, terrible integral that I don't want to do. There it is, and I have no desire to find that by hand. So I will make Maple do it. It's good for me. And here it is. So I took 1 over, and I actually originally typed the original one in, just so I could make sure that this worked out the same way as that reduced one, well, not reduced, but further along one did. So in doing this, if I'm forced to do the first steps by hand and then only do the last part with Maple, there's nothing stopping you from using Maple to do the whole thing, but then just double checking your work this way, which is what I'm doing. So sure enough, the original integral is in fact equal to my modified integral, and it's all 16 over 11. So that would be x bar, excuse me. So x bar is 16 over 11. So I have one coordinate in my center of mass. Now, if you'll notice, this particular line, or this particular region, is symmetric around the line y equals x, and so is the density function, right? So symmetric around y equals x. But if you didn't see that, you could do the whole thing over again, but with y. So y bar would be mx over m, which is 1 over m, but then multiplying that density function times y in that integrand. So that would be the same function I had before. So 1 over 88 over 3, same limits of integration, but then I multiply by y. So 1y is y, xy, and y squared. And then I integrate that with respect to y, so that's a little bit uglier, but I mean I can do it. So 1/2 y squared plus x over 2y squared plus 1/3 y cubed. I'm going to stick 4 minus x onto all that, but before I even do that, I kind of noticed that these two terms are like terms. So I factored the y squared out, and that left me 1 plus x over 2, or a half plus x over 2. Just easier for the next step, because then I have 3 over 88, and that 1 plus x over 2 is right there. And then for y, I put the 4 minus x in, and then over here with the y cubed, I put 4 minus x in. And again, when I do it in Maple, I'm going to get the same answer I got before, which is 16 over 11. Here it is right here, in case you don't believe me. Right? Okay, so they're the same. So the center of mass would be x bar, y bar, which is 16 over 11, 16 over 11. And both of those units are in centimeters, because what you're talking about is the distance from each of those axes. So how far is the center of mass away from the x-axis and the y-axis? You just found it's 16 over 11 centimeters for both. And it ended up being the same because both the density and the functions were symmetric around the line y equals x. All right, so that's the end of that one.